Hi. Now on the previous lesson we factorized expressions with 2 or 4 terms. Now today we'll factorize expressions with 3 terms. And in the first questions we'll make use of this formula which we've used previously on the first lesson from the right hand side to the left hand side for opening brackets. But today we'll do it from the left hand side to the right hand side. So we'll start with something like this and we want to end up with an expression like this. Now, first of all, to be able to use this formula, you'll have to check that your first term and last term are squares of something. Now, in our first example, let's check that. So let's ask ourselves whether 63x squared is a square of something. Well, it is a square of 6x because 6 squared is 36 and x squared is x squared. Then let's check the 1. Is 1 a square of anything? Well, it is because 1 squared is 1. Now, why did I put minus 1 squared in there? I took it from here. So the sign of the second term in the expression tells you the sign of that. So that is negative 1 squared. Then the term in the middle, this one, should be 2 times that. So this negative 12 squared, is it 2 times 6x times minus 1? Well, it is because 2 times 6 is 12 times negative 1 is negative 12 and then times the x. So our expression is of that form and that's why we can use it to write it in this form. And now our a in here is 6x and our b is negative 1. So we can write this as 6x plus minus 1 and in brackets and squared. Now b. We'd have to start with the same question for whether the first term is a square of something and whether the last term is a square of something else. Well, 50 isn't a square of any integer, so no integer to the power of 2 makes 50. The same with 18, so no integer to the power of 2 makes 80. But we can see that all these 3 terms, all the coefficients, have a common factor because they can all be divided by 2. And we would want the first and the last terms to be positive because only positive numbers can be square of something. So we'll factorize all the terms for negative 2. And then we'll think, what times negative 2 gives negative 50x squared? Well, 25 times negative 2 is negative 50, and then you'd have to have the x squared in there. Then for this, what times negative 2 makes positive 60x? Well, negative 30 times negative 2 is positive 60, and then times the x. The last term in here, what times negative 2 is negative 18. Well, positive 9 times negative 2 is negative 18. And then we'll see that we have 3 terms inside the brackets, and let's try using this again. So check the first term inside the brackets and the last term inside the brackets and see whether they are squares of any terms. Well, 25 is a square of 5 and x squared is a square of x, so this is the square of 5x, and then we have a minus sign in here, and this is a plus 9, so negative 3 squared is plus 9. Then check whether the middle term is 2 times our a times b, so whether this is 2 times 5x times negative 3. Well, 2 times 5 is 10, times negative 3 is negative 30, and times x, so this makes that. So our a is 5x and our b is negative 3. So we can write this as 5x plus minus 3 and squared. Now we have another way of factorizing expressions with 3 terms too. And we're going to use this formula for that. Now, where does this formula come from? Because we haven't used it previously. Well, if we open the brackets from the right-hand side, we would get x times x plus x times b. And a times x times a plus a times b. And in here we can see that x times x is x squared, a plus b is a plus b, and from the 2 terms in the middle, we can take the common factor of x, and then inside the brackets we'll have b plus a or a plus b. So we can see that this, when opening brackets, gives that. And now for factorization, we're going to use it from the left-hand side to the right-hand side. Now, to be able to use this formula, you'll have to check that the coefficient of x squared is 1, and that the coefficient of x is a plus b, and then the constant term, it would be a times b. Let's see how this works in practice. Now, in our example, we'll first check that the coefficient of x squared is 1. Well, it is. Then we'll try to figure out numbers, 2 numbers, so that their sum would be positive 2 and their product would be negative 3. Well, 3 and negative 1 are such numbers because 3 plus minus 1 makes positive 2, and 3 times minus 1 gives negative 3. So our a is 3 and b is negative 1. So we can write it as x plus a times x minus b. It doesn't matter in which order you've written them. So x plus 3 times x minus 1 is the same thing as x minus 1 times x plus 3. B. Now, we would have to check whether the coefficient of x squared is 1. Well, it's not. So we would have to do something to this so that the coefficient of x squared is 1. Well, what we can do is we can factorize all the terms by negative 3 because all the coefficients are divisible by negative 3. So negative 3 inside in front of the brackets, and then we'll think what times negative 3 is negative 3x squared? Well, it's x squared. What times negative 3 is positive 21x? Well, negative 7 times negative 3 is positive 21, and the x from here. Then what times negative 3 is negative 30? Well, positive 10 times negative 3 is negative 30. And now if we have a look at the terms inside the brackets, then we can see that inside the brackets, the coefficient of x squared is 1. And then let's try to figure out the two numbers so that their sum is -7 and their product is +10. Well, those numbers are -2 and -5, because -2 plus -5 is -7, and -2 times -5 is +10. And that's why you can write the whole of these as -3 times, and then x plus -2 times x plus -5. And you can leave the plus from here because plus times minus is minus.